before you get there.
Are those the
You think you buy it at the store?
No.
Is that water?
Okay, so what we're looking at in this case, and what I really want you to focus on with this heat is what's going on. How do you feel? I mean, what are you feeling as this goes? You can feel the heat, but here's my question: are you standing in the flame? No. So then, why do you feel heat?
It's so hot.
Okay, so good. We recognize that this energy in this case is being transferred as a wave. Good. That's a start. Okay. And then, how though is it getting to you? How is it being transferred from that wave? Air. Okay, good. So from air. All right. Well, I'll call that.
Is that like water or what is that?
This is methyl alcohol.
Can we get some of that?
Maybe.
Where do we get it?
Whoa.
Oh, it's burning inside the thing.
Where?
On the side.
Still burning?
No, it's gone.
Okay, so when we're looking at heat, we're talking about energy in the form of heat. Okay, we're talking about waves of energy that are being transferred. Now, what's really happening here, and why you can feel this, and why you can also feel this is, the air molecules over the top of this desk are being excited by the energy from the heat. And as they're excited, they bump into the air molecule next to them, next to the air molecule next to them, and so on, in a process called convection. Okay, and that heat is convected toward you by bumping one after the other, after the other, after the other. Clear over here to Dylan, who then goes, whoa, gets hit with a nice energized air molecule and says, wow, that's hot. Okay, not like Paris Hilton, like, oh, that's hot. But like, but like, wow, that's hot. Okay, so that's heat. Okay, that's heat. That's how heat operates. Thermal energy happens in a lot of cases. It doesn't always produce flame. It doesn't always produce flame. For example, you take your hands and rub them together for a while, and you feel heat. That's thermal energy also, and it's coming from friction. Okay. Now, we're going to take and use heat to produce light. Okay, so you could write down what you smell, you could write down what you see, yeah, exactly. Write down your observation. It's kind of a chemically smell. Fuel? Sure. Yeah, fuel. So, what I'm going to do is I'm going to freshen up my little bit of methanol in each of these things. Okay, what we're going to do here is we're going to use a little bit of your knowledge from chemistry to go through and see how much you can remember with regards to the periodic table. Okay, remember when we talked about the periodic table, we talked about how some of these chemicals have different energy levels, right, based on which period they're in on the table. Well, what you're going to see here is as we energize these, sometimes it'll take an electron at a lower energy level and kick it up to a higher energy level. And when it does that, those electrons are stuck in a spot where they're unstable. They don't want to be there. So they drop that energy out. That energy is released in the form of light. Depending how much energy is released, what you'll end up getting is colors of different wavelengths. And so you'll see what I mean here in a minute. So we're going to start with something very basic. This is table salt and alcohol. That's it. Just table salt and alcohol. So give it a second to burn the alcohol off, and it'll actually start burning some of the salt. Yeah, it's just getting burned. So now you're seeing the color of the salt itself burning. In this case, sodium chloride, and it is burning in a yellowish-orange flame. Okay, that's because the energy level there is being kicked up to, whatever energy level it's being kicked up to, and then releasing. It's giving us a yellow. The next one is barium chloride. Barium chloride is down in the sixth period. Okay, it's down a little bit lower, so it's going to have a little bit different energy level, meaning it's going to have a different wavelength ultimately when the energy is released. So, give it a second. It's hard to see next to the nice bright yellow, but you can kind of see a pinkish kind of color. Yeah. That's the barium chloride. Now that's a different energy level. Different energy level. Okay. The next one of my personal favorites, lithium chloride. Give it a second. It's blue to begin with, and then it gets red. Oh. Give it just a second. Just wait. Told you I was Harry Potter. I'm just playing. That's lithium chloride. Cupric chloride.
Whoa.
Yeah, write down what you see.
I see fire.
The green one is cupric chloride. It's copper and chloride mixed together.
Cooper?
Not
Alex.
copper. Not Isaiah. The pink one's barium chloride.
That's so cool.
What's the blue one?
What's the white one now?
The white one, that's the barium. And then the last one is strontium chloride. And I apologize. Strontium chloride should be burning a darker red than the lithium, and it's not. I don't know why. But something's wrong with it. It's burning more like the sodium chloride, but I'll go ahead and do it anyway. It gives us kind of a little bit more of a darker orange, I think, than the sodium chloride. But what you're seeing is the difference, the only difference between these things. It's the same fuel source all the way across. Same exact fuel source.